In this video, I want to give you a short introduction to solving one-step equations, specifically by using multiplication and division to isolate our variable. So we have x equals or y equals. All right, so in this first example, we see that we have negative 6x equals 42. Remember, when you have a number in front of a variable, this is called a coefficient, and the operation that we're dealing with is multiplication. This is negative 6 times x equals 42. So if we're trying to isolate this variable x, we need to get rid of this negative 6 from this left side. And right now this negative 6 is being multiplied by x, so we will do the inverse operation of multiplication. So let's go ahead and divide both sides of this equation by negative 6. This is called the division property of equality, and it just states that if we're going to divide one side of the equation by some value, we need to also do it to the other side to make sure everything stays nice and equal. So on this left side, the negative 6 divided by negative 6 will cancel out and become just a 1 or a 1x or just x. And then on the right side, we have this 42 divided by negative 6. And so 42 divided by 6 is 7, and a positive divided by a negative is a negative. So in this first example, we use the division property of equality. We divided both sides by negative 6 to isolate our variable x. So in doing so, we see that x equals negative 7. And of course, it's always nice to plug it back in to make sure that it works. So we have negative 6x, and x is negative 7. We're going to say that equals 42. So a negative times a negative makes a positive, and 6 times 7 is 42. And we see that positive 42 equals 42, so indeed it does work. In this second example, we have y, which is our variable, our unknown value for which we're solving, and that's being divided by negative 4. And when we do this division, we get negative 3. So in an effort to isolate this y variable, we need to do the opposite or the inverse operation of dividing by negative 4. So let's go ahead and multiply both sides by negative 4. This is called the multiplication property of equality, and it just states that if I multiply one side of an equation by a value, I need to also multiply the other side by that same value to keep everything nice and equal. So on this left side, the multiplication by negative 4 and the division by negative 4 cancel each other out, leaving us with just a 1 or a 1y. Or just y. And so y equals, and we just need to do this multiplication. Negative 3 times negative 4 is a positive 12. So in this case, the value for y will be positive 12. So let's go ahead and plug that back into our equation and just make sure that that works. So y divided by negative 4, so 12 divided by negative 4 equals negative 3. So a positive divided by a negative is a negative. 12 divided by 4 is 3. So we see that negative 3 does indeed equal negative 3 for the second example. In this third example, we're going to look at an equation with fractions, and we're going to address a very important property here. Okay, so we have 16/7 equals 40/21 times n. So remember, when you have this coefficient and the variable right next to it, it means multiplication. So in an effort to get this n variable all by itself on this right side, we see that we need to do the inverse of multiplying by 40 over 21, which is going to be dividing by 40 over 21. But remember that when you are dividing a fraction, isn't that the same as multiplying by its reciprocal? So instead of specifically calling this the division property of equality and working through and dividing both sides by 40 over 21, we're going to change it up just a little because we know that division by a fraction is really multiplication. So what we're going to do is multiply both sides of the equation by this reciprocal. Because remember, our goal is to get rid of the 40 over 21 off of this right side with the n, And so we will multiply by the reciprocal, and it'll be 21 over 40 on both sides of the equation. And of course, this is using our multiplication property of equality, which just says that if you multiply a value on one side of the equation, you need to also do it on the other side to keep everything nice and equal. Over here on the right side, you'll see some nice things because, of course, the 40s cancel and the 21s cancel. We've got just ones everywhere. So our n is indeed by itself. On the left side, though, we have this fraction multiplication that we need to go ahead and do. So it looks like we can factor and cancel some things in these fractions. So the 21 and the 7, I could divide a 7 out of each of these, and I'm left with a 3 and a 1 respectively. The 40 and the 16, it looks like I can divide an 8 out of both of these, so I'll be left with 5 and 2 respectively. So in this multiplication, it looks like I have 3 times 2 and 5 times 1. So it'll be 6 over 5. So I can say my value for n is going to be 6/5. But one more step that we could consider, some students don't like to see the variable over here on the right side. So we can switch these two and we can say instead n equals 6/5. And so what property allows us to do this? Well, it's called the symmetric property of equality, and it just states that if we have two expressions that are being set equal to one another, then we can go ahead and exchange the left for the right or the right for the left and just change those two around and say instead n equals 6/5. And once again, to recap, when we had a fractional coefficient here, so this 40 over 21 being multiplied by n, we're going to multiply both sides of this equation by the reciprocal. So we're going to flip that turkey over and call it 21 over 40 and multiply both sides of the equation that way. In this fourth and final example, we're going to look at this equation that includes decimals. So it looks like we have 0.07 times m, or if you want to read it in proper form, it's 7/100 m equals negative 4.9, or negative 4 9/10. Okay, so once again we see that this coefficient here is being multiplied by my variable. So in order to undo this multiplication, the inverse operation will be division. So we're going to divide both sides of this equation by 0.07. Of course, on the left side, that's easy because they'll just cancel out. But on the right side, it appears that we have this negative 4.9 divided by 0.07. So we have a fraction, but our fraction includes decimals. So maybe we don't like that very much. How can we simplify this? Well, let's go ahead and look at how we can simplify this. Okay, so I'm going to rewrite it here over on the right side a little bit here. So we need to get rid of the decimals that are kind of plaguing our fraction here because we don't like to have a fraction with decimals included. So what we're going to do, we're going to look at the decimal that contains the most decimal digits. This one has 1 decimal digit, so the 9 after the point or after the decimal. And this one has 2 decimal digits, a 0 and a 7 after the point or the decimal. So what we're going to do is we're going to move this decimal to the right once, twice. And we're going to do it on the top as well, once, twice. But you'll see in the top we have this kind of space or this openness right here, so we're going to go ahead and fill it with a 0. So what did we really do here? Well, I multiplied the bottom by 100 because powers of 10, when you multiply, will move that decimal to the right. So what do we do on top? Well, once again, we multiplied by 100. So this is just like getting a common denominator when you have to scale the numerator and the denominator. So we've multiplied by 100 over 100, which is just really multiplying by 1. So I haven't changed the value here, but I am changing the form that it's in. So what will that look like now? Well, now I have negative 490 divided by, well, 7. Okay, well, the negative divided by a positive will be a negative, and 490 divided by 7 is 70. So I'm able now to say that my variable m equals negative 4.9 divided by 0.07, which is negative 70. And if you go ahead and plug that back in, so you have 0.07 times negative 70, you will see that it indeed does equal negative 4.9. So that'll work out just fine. So once again, we divided both sides using our division property of equality, and we divided it by this coefficient of our variable m. But it kind of led us to an interesting situation where I had a fraction that included decimals on the top and the bottom. So what I did was multiply the top and bottom of the fraction by powers of 10 in order to move that decimal place. So we moved it twice on the bottom, twice on the top, filled it in with a 0 where necessary, and then this division became very simple to do. Negative 490 divided by 7 was our negative 70.